Hello, my name is Beata Bogdanska and I will talk to you about eye tracking data and attention in terms of saliency analysis in video. What is saliency? Saliency is the ability of an object to attract attention. Take a look at this clip of rising sun. Notice how your eyes immediately focus on the brightest point in the image, the sun. It means that in this image, the sun is the salient point. Sometimes there can be more than one salient point in an image. Notice as the sun is rising and more details are revealed in the image, your gaze starts to focus on the sea and the continents. It means that those elements are now becoming salient too. What is eye tracking? Saliency is measured by eye tracking experiments. An eye tracking machine can change a stimuli presented to a participant into a heat map. Heat map is an image that shows where the participant has looked and which parts of the image he ignored. What are the applications of eye tracking? Eye tracking is used in various fields, mainly in ergonomy and usability research, computer vision, visual quality assessment, psychology, marketing, and neuroscience. Still image eye tracking. So, what exactly is happening during eye tracking? When participant's eye reacts to the stimuli presented, its movements are registered by a camera in the eye tracker equipment. Next, this data is converted into X and Y coordinates, indicating points in the image on which participant focused. Next, these coordinates are written into a file. Later on, they are transformed into a heat map. Heat maps created with images give immediate indication of what was interesting and what attracted attention of the viewer. Eye tracking in video. This type of analysis is not so easily performed when it comes to videos. Why? Because we get a lot of single images, frames in a video. For each of this frame, we get a small amount of coordinates, so the heat map created based on this data is not always indicative. If we want to create a heat map for all of the frames, we also get a lot of heat maps. It might be enough when you just need an indication of what is interesting, but to compare patterns and changes, statistical methods are required. We simply get too much noise in each of the heat maps to make sense of the data. How can we resolve this problem? Our solution may seem pretty straightforward. We want to combine heat maps from several consecutive frames to create a more accurate representation of the viewing behavior of the observant. It is not as simple as it seems. Currently, we are working on an algorithm to establish how many frames should we combine for the optimal effect. Hopefully, as a result, we will obtain a highly precise and indicative heat map for parts of the video, just like for still images.